So this is the third video on factoring or reviewing for the test for the retake. The first two videos covered the previous sections. So video 1 covers 1 through 8, video 2 covers 9 through 14, and we are on video 3, starting with perfect square, quadratic trinomials, and binomials. So on number 15, you have to recognize that there's a perfect square term here and a perfect square term there. And when you have perfect square terms like that, you're going to be able to use a shortcut and simply square root the 4x squared, and you'll end up with 2x, and you square root the 25, and you end up with 5, and you repeat it, 2x and 5. Now the question is, what symbols, what signs belong here and here, right? In order for you to get a negative 25 at the very end, well, one has to be a positive 5 and one has to be a negative 5. So one has to be positive, one has to be negative in order for you to get a negative 25. Not only that, when you distribute and combine like terms, the middle terms have to eliminate because it's a binomial, not a trinomial. That's why it's important to have different signs, a plus and a minus. And that's pretty much all there is to it. That's your factored form for number 15. Number 16, a lot of people see the perfect square term and the perfect square term, and they think, oh, this is going to be easy. The square root of 9x squared is 3x. The square root of 49 is 7. So you write the 3x and the 7. Now the challenging part is to think what signs belong in here. Is it going to be a positive positive, a negative negative, or a plus and a negative? What do you guys say? It doesn't work. That's right. Now, in order for you to get a positive 49 at the very end of your distribution problem, it would have to be either a positive 7 times a positive 7 or a negative 7 times a negative 7. But we know that the only way you'll end up with a binomial instead of a trinomial is if they're different. One's a negative, one's a positive. But you can't end up with a positive 49 if you have a negative 7 times a positive 7. I guess what I'm trying to say is prime is the answer for number 16. It's not factorable, so we just write prime. So on number 17, once again, whenever you recognize that you have a perfect square term as your first term and a perfect square term as your last term, you might as well try to square root them and plug them into your answer format. So the square root of 25x squared is 5x. The square root of 4 is 2. Now, this is the only interesting part where you need to decide what symbols belong here. Now, in order for you to get a positive 4 at the very end of a distribution problem, you have to have a positive 2 times a positive 2 to get positive 4, or maybe a negative 2 times a negative 2 to get positive 4. So what do you guys think? If your middle sign is negative, then both of these cannot be positive, because if everything's positive, then everything would be positive. But we know that the middle term is negative. So it can't be a positive and a positive. What's it going to be? Both negative. That's right. Negative and a negative. And of course, it would be smart to distribute to double check your answer. So 5x times 5x is 25x squared. 5x times negative 2 is negative 10x. Negative 2 times 5x is negative 10x. And negative 2 times negative 2 is positive 4. As you can see, the middle terms really do give me that middle value of negative 20. So I know I did it right. This is my correct answer up here. Number 18, once again, we have a perfect square term, a perfect square term. Let's square root those bad boys and get the answer. What's the square root of 4y squared? 2y. What's the square root of 49? 7. Now, if the middle term is negative, what kind of signs do we have right there? Both negative. Now, if this middle term would have been positive, that means everything would have been positive. That means I'd have 2 positives. But it's negative. So, if you check your answer, it'll work. Let's check. 2y times 2y, 2y squared. 2y times negative 7, that's negative 14y. Negative 7 times 2y, that's another negative 14y. Negative 7 times negative 7, that's positive 49. When you combine the middle terms, you really do get the negative 28y that we have in the middle. So we know for a fact that this is the correct answer, the factored form for number 18. Let's move on to number 19. Once again, we have a perfect square term, write it in our factored form answer format. The square root of 9n squared is 3n. The square root of 25 is 5. When I start thinking of the signs, how could I get a negative 25 at the very end? It would have to be a negative times a positive, right? In order to get the negative 25 at the very end. But we know that if we have different signs in the middle, it's going to cancel out the middle term, so you wouldn't have a trinomial, you have a binomial. So what does that mean?
Prime.
That means prime. Once again, you cannot do it. I mean, you think about it, but you can't do it, so you write prime. Let's move on. So on the back side of our worksheet, we're going to pick up on number 20. And this first section of the back side says factor completely. And if you read right here, it says pull out the GCF and then continue factoring with other methods. So let's take a look at number 20. And it tells you to pull out a GCF. So what is the GCF on number 20? 4. And if you do pull out a 4, what do you have left? 4p squared minus 9. Now on the inside, I probably should have done this a different color. Let's look at this blue binomial and recognize that it's a perfect square binomial. So on the inside, we could continue working. If you take the square root of 4p squared, what will that be? What's the square root of 4p squared? 2p. And what's the square root of 9? 3. Now, since it's a binomial, the middle terms have to cancel out. So what does that tell you about the signs? Mixed signs. One positive, one negative. And what about that 4 that we pulled out originally? You have to bring it down. That's your completely factored form of number 20. So once again, on this section, we're pulling out the GCF first, and then looking at the inside and continuing to see if we could do anything. So right here on number 21, what could I pull out first? Bless you. A 2. And when we pull out that 2, what do we have left?
25x squared.
25x squared plus 30x plus 9. And now if you look at the inside of the parentheses, we have a perfect square quadratic trinomial in blue, which means I could take the square root of that guy, take the square root of this guy, and rewrite it in factored form again. So the square root of 25x squared is 5x. Square root of 9 is 3. 5x, 3. And when you're thinking about the symbols, the signs, if everything's positive, then that's easy. Everything's going to be positive. Put a plus there, plus there. What about that 2? Bring it down. So there's your final factored form. Oh yeah, by the way, if you see the same exact binomial written twice, you could technically write it as 5x plus 3 in parentheses with the square on the outside. That is totally up to you, though. I'm going to move on to number 22. Now, if you had the original copy, there was a typo on it. This plus should be a minus, okay? So that's not there. It should be a minus right there. Let me rewrite the whole thing. I apologize. Anyway, from there, let's pull out the GCF, which is a 2 and an x. If you pull out a 2x, on the inside of the parentheses, you will have x squared minus 4x minus 12. And if you look at that blue quadratic trinomial, you could factor that further. All you got to do is think what times what is negative 12, that if you combine together is negative 4. That would be a negative 6 times a positive 2. And don't forget about the 2x that's out in the front. And that is your completely factored form of number 22. Jumping to number 23. So on this final section, it says solve the following equations. And we need to remember the zero product property. If you do have something times something equals 0, then that first something could be 0 or the second something could be 0. So that's exactly what we do. We split them. We take the 4x plus 12 and set it equal to 0. Take the 3x minus 2 and set it equal to 0. Then you solve each of them. Subtract 12. You end up with 4x equals negative 12. Your final step would be to divide by 4 and divide by 4. So x equals negative 3. Now, in the other equation, we have to get rid of the minus 2 by doing the opposite plus 2. What you do to one side, you do to the other side. We have 3x left over equals 2. Final step would be to divide by 3, and we'd get our final answer, x equals 2/3. This one's particularly easy because it's already in factored form. You have a binomial times a binomial, and it's set equal to 0. So when it's already in factored form, all you have to do is split them and solve. But sometimes you don't have them in factored form. So you need to solve this equation. Now there's a couple of thoughts that could be going on through your head. One is to get x by itself, but the problem is you have x squares and x's, so you can't really get one of those by themselves because there's two types of x's. So we're not going to try to get x by itself. We are going to, again, try to set it equal to 0 and then factor to get something times something equal to 0 and then split them and solve. So let's first set it equal to 0 by adding 7x and adding 7x. So we're going to rewrite what we have because you cannot really add 7x with 6x squared. They're not like terms. You can't even add 7x with 2. You can't do it. So let's just rewrite it. So we have this new quadratic trinomial equation that's set equal to 0. Now what we need to do is think, we want a factor to be able to end up with this, to be able to split them and solve. But the problem is, sorry about that. Again, that's probably one of the longest questions there is on this whole practice test or study guide. Let's move on. Number 25. Again, we have an equation. We want it to be equal to 0. So I am going to get rid of the minus, I want to get rid of the plus 18x by subtracting 18x. That'll give me 0. What I do to one side, I do to the other side, minus 18x. And I also want to get rid of the 20, so I'm going to subtract 20 and subtract 20. Now notice that you can't really do 2x squared take away 18x. They're not like terms. Just like you can't do 18x take away 20, you can't do it. They're not like terms. So we're going to rewrite everything. We're going to have a 2x squared minus 18x minus 20. The equal sign comes down, and of course there's nothing left over on the right side. So now that we have it set equal to 0, I could try to factor, split, and solve. What's the first type of factoring we should try to do? GCF. What is the GCF of that quadratic trinomial? 2. So if we pull out a 2, what would be left?
X squared minus 10.
Now inside the parentheses, we have a blue quadratic trinomial. The a value of that blue quadratic trinomial is 1, right? There's no number right here in the front. So that means that we could do the simplest type of factoring by putting an x and an x and simply think what times what is the c value that if I combine together is the b value. So what times what is negative 10 that if I combine together is negative 9. If you're confused, you could make a list. The only way to get negative 10 is negative 1 times 10 or negative 2 times 5. Which pair of numbers gives you a 9? The negative 1 and 10, but that'll give you a positive 9, and we know we want a negative 9. So we're going to change the signs. We have the right numbers, we just have the wrong signs. So make it a positive 1 and a negative 10. So on our factored form answer, it's going to be a positive 1 and a negative 10. Now let's not forget that we had an outside 2, that GCF we pulled out. So I'm going to rewrite everything. Let me show you that. Outside 2, I'm going to bring it down. The parenthesis, x plus 1, the x minus 10. And let's remember that this was an equation to start with. So we still need to put the equal 0 at the very end. And now from here, we need to solve it. So I'm going to get rid of the 2 by simply dividing by 2. It'll cancel out. What I do to one side, I do to the other side. Divide by 2. 0 divided by 2 is still 0. So we end up with something times something still equaling 0. So we're going to use the 0 product property to split them and solve. So on the left equation, you subtract 1, you get x equals negative 1. And on the right equation, you add 10, you get x equaling 10. So those are your two answers for that one. Number 26, we finally get to an equation where we apply a square root. Okay, so what's the difference between 25 and 26? 25 had an x squared and it also had an x. So you cannot try to get x by itself because there's two types of x's. But 26 only has one x inside the parentheses. So since you only have one x, you could try to get it by itself. And how do you get rid of something? You do the opposite. So if you see a square and you want to get rid of a square, you do the opposite of a square, which is a square root. And what you do to one side, you must do to the other. However, when you apply a square root, you must put a plus or minus in front of your answer. So the square root of 1 is really a plus or minus 1. Now on the left side, the square root that you applied and the square, those cancel out. So you will be left with an x minus 4 left over on the left side. So we still need to solve, get rid of that minus 4 by doing the opposite, plus 4 and plus 4. This cancels. Now this is what I recommend. Rewrite everything. Bring down your x, bring down the equal sign, and rewrite this. In other words, positive 4 plus or minus 1. Now the reason why I recommend that is because that's going to be two answers. It's going to be 4 plus 1, and it's also going to be 4 minus 1. So 4 plus 1 is 5, 4 minus 1 is 3. Those are your two answers for that one problem, 5 and 3. Number 27. It's another one similar to that. Step 1, apply the square root. You will only have an x minus 16 left over, the equal sign, but then again we took the square root of 9, which means we're going to have a plus minus right in front of our answer 3. Final step would be to add 16. Add 16, I say rewrite it. X equals positive 16 plus or minus 3. That way you could actually write both situations, 16 plus 3 and also 16 minus 3. So yes, the correct answers are 19 and 13. Number 28. This is a different type of problem. You could actually do it many different ways. You could set it equal to 0 and then factor the perfect square quadratic binomial. Or you could just get rid of things by doing the opposite. So maybe I could do one way and do the other, number 29, a different way. I want to do this one by getting rid of the 36. So it says 36 times x squared. I could get rid of that multiplication of 36 by dividing by 36. That'll cancel it out. What I do to one side, I must do to the other. So I will have x squared equals 25 over 36. And we should all know to get rid of a square, we're going to apply a square root to both sides. So I will have x equals, and when we do apply a square root, we need to put a plus or minus right in front of our answer. Now when we have the square root of a fraction like that, especially if they have perfect square numbers on top and bottom, it's good to split the square root and do the square root of 25 and do the square root of 36, thus giving you your final answer, plus or minus 5 over 6. So that's actually two answers, x equals positive 5 over 6 and also x equals negative 5 over 6. Now, you didn't have to do it this way where you get x by itself and then you apply a square root. You could have done it this other way. Let me show you. Look at number 29. We could have factored by subtracting 4 and subtracting 4. You'd have 9x squared minus 4 equals 0. And then you could recognize there's a perfect square term here, a perfect square term there. So you could actually factor it by taking the square root of those guys and plug them into your factored form answer format. So the square root of 9x squared is 3x. The square root of 4 is 2. Since it's a binomial, not a trinomial, we know that the middle terms have to cancel out by having opposite signs. And then after that, all you have to do is split it and solve. So I will have 3x plus 2 equals 0, 3x minus 2 equals 0. And when you solve, you subtract 2. You'll have 3x equals negative 2. Final step would be to divide by 3. So you get x equals negative 2/3. And if you do the same to the other, plus 2, 3x equals 2. Divide by 3, x equals positive 2/3. Now, as you can see, we have the positive 2/3 and the negative 2/3. So if we did it the other way, we'd get the same exact answer, x equals plus or minus 2/3. Honestly, getting x by itself and using the square root is faster, right? You could have simply divided by 9 first. Divided by 9, might as well do it. Have a x squared equals, if you divide by 9, you'll have a 4 divided by 9. And then you apply the square root, which means x equals plus or minus, and the square root of 4 is 2, and the square root of 9 is 3. So see how much faster it is applying the square root? It's totally up to you guys if you want to use the quicker method or the longer method. It's totally up to you. Anyways, I'm done with this last video on this retake study guide for the retake test.